negative energy states in quantum mechanics. This is today's topic. So we are talking about the subject quantum mechanics, and the term negative energy is being used. Yes, in the study of science, specifically physics, chemistry is also there, you know. So in the study of physics, very often you may come across negative energies. Sometimes, in most of the cases, what happens, you are solving a problem by using mathematics, and the result of the mathematics, say the variable is energy. Okay, variable is energy. Say we are talking about kinetic energy, and when you are solving the equation, okay, you are getting negative value of kinetic energy. Then how would you explain this? You know that kinetic energy, the formula used for kinetic energy is half mv square. That is half into mass into square of the velocity. You know that mass is a positive quantity. Velocity may be negative or positive, but square of velocity appears here. So square of velocity is always positive, because velocity is negative or positive, but it is a real number. It is not a complex number. So square of any real number, whether it is negative or positive, it must be a positive quantity. Square is involved there. That means half mv square is always positive. That means you are sure that kinetic energy should always be positive. It cannot be negative. Since you are 100% sure about this, then if from mathematical equations, if you get negative value of kinetic energy, that means, how will you explain this? In that case, your explanation will be that there is some mistake in my mathematics. There is some mistake in my calculation. This way you will interpret your result. Am I right? Again, you have seen that in the study of rectilinear motion or any motion problem involving time. Say, you have found out the value of time for a particular to reach from this point to this point. Say you have solved a quadratic equation for time. If you are a student of physics, you know that. For the calculation of time, very often we come across quadratic equations. Okay. So suppose after solving the equation, you are getting two values of time. One is negative, another one is positive. So you are habituated in accepting the only positive value. Am I right? Yes, this value is right, and since time cannot be negative, so this value is discarded. Means this is ignored. This value cannot be accepted. The negative value of time cannot be accepted. That means you have some logic. You are using some logic whether the negative value of time or the negative value of kinetic energy can be accepted or not. But in the study of physics, many fields are there where so easily you cannot decide whether the negative value is accepted or not, whether the negative value can be accepted or not. Many situations are there. I have noted down few situations here. Okay, I am just reading out. You can see everything on the screen. Gravitational energy. Okay. Then comes black hole, ergosphere. Then there are so many quantum field theories. Means there are so many quantum field phenomena such as virtual particles, Casimir effect, squeezed light. Okay. Then Dirac-C, ACSC. Quantum gravity, Hawking radiation, wormholes are there, warp drive, relativistic quantum theory. In all these cases, you will get negative energies for certain solutions. If you are going to solve Schrödinger's equation, Schrödinger's equation in quantum mechanics, in many cases you will get negative result of energy. So scientists try to accept those negative energies. Try to accept. It is not always possible to accept all the negative values of energies. Try to accept, but whenever you are trying to accept the negative value of energies, that means you are trying to explain how this is possible. Such as for antimatter, negative energy is possible. This is the opinion of the scientists. For virtual particles, if you talk about virtual particles, in those cases also, scientists are accepting negative values of energies. So many things are there, so many points I have noted down here. In all the cases, you will come across negative energies, but not in all the cases, all the negative energies are accepted. It is a case of debate in scientific community, okay, whether the negative values of energies will be accepted, can be accepted or not. Anyway, in today's lecture, I am going to focus on this point, that is black hole ergosphere. I want to say something about this black hole ergosphere. You know black holes, this is known to you. Rotating black holes are also there. Black holes rotating about their own axis are called rotating black holes. So if gravitational field of the rotating black hole is if it is very high, gravitational field of the rotating black hole, if it is very high, in that case, surrounding that black hole, outside the event horizon of that black hole, there is a region of space-time which is called ergosphere. That ergosphere also rotates with the black hole in the same direction as the black hole rotates. And if there is one particle inside the ergosphere, then that particle, not only one particle, there may be trillions of particles, okay? I am talking about only one particle. Say there is one particle inside the ergosphere. So that particle also rotates with the black hole. That particle cannot go against the direction of the rotation of black hole. Why? Because there is huge gravitational attraction. There is huge gravitational pull of the black hole. Okay, that's why the particle inside the ergosphere must rotate with the black hole. Okay, while it is rotating, it splits into two. When it splits into two, or if the particle crosses the boundary of the event horizon, you know event horizon, it is a boundary, it is an imaginary boundary beyond which escape is not possible. So when a particle inside the ergosphere splits into two, so there is a chance of negative as well as positive energy. One particle will have negative energy, other particle will have positive energy. These are the theories developed by scientists. There is no experimental verification yet. Just keep in your mind that there is still no experimental verification of such theories. It is at present, this is just in theory level. So one particle reaches to the black hole, means crosses the event horizon and reaches to the black hole. Which one? Particle with the negative energy. And when the particle with negative energy reaches to the black hole, and due to the conservation of energy principle, some positive energy must come out from the black hole. That positive energy is with respect to an observer who is at infinite distance from the black hole. The observer is located at an infinite distance from the black hole. How all these things are happening, these are still unknown. Scientists are trying to explain such things this way by taking the help, by making the concept of negative energies. Okay. So this was all about, and so many points I have written here, you can see, and I have given you one example that Schrödinger equation is known to you. Okay, when you are solving Schrödinger equation, there also you will get, in many cases, not in all the cases, in many cases you will get negative values of energies. And those values are not readily rejected by the scientists. Okay, this value is negative. We are getting negative value of energy, so this is discarded. This cannot be accepted. No, it is not that much easy, because you are already familiar with the puzzles in quantum mechanics. Our day-to-day life experience does not match with the phenomena observed in quantum mechanics, in the field of quantum mechanics. So whenever you are getting something puzzling in the field of quantum mechanics, means when you are conducting experiments related to quantum phenomena, and if you are getting some confusing result or puzzling results, then in that case you should not ignore those results or discard those results so easily. How? In many cases, almost in all the cases, we ignore something because our day-to-day life experience does not match with those things. If it does not match, we ignore all those things very easily. Always what we do, we compare the result with our previous knowledge or previous experience, and if it is not matching with our previous knowledge or previous experience, in that case we ignore all those things. No, this is not possible. We are habituated in making such discussions. Okay. Anyway, so this was all about this video. So my focus was on only this point, that is black hole ergosphere. In my next video, just next to this video, okay, I'll talk only about this black hole ergosphere. How in black holes negative energy particles are formed. Okay. Okay, so this is the end of this video. Thank you. Thank you for watching this video.